Syngap land. My name is Michael Graglia, and today is Thursday, January 27th, year 2022. This is episode 44, Syngap 10, your 10-minute weekly briefing on everything you need to know about Syngap 1. And I should have done this on Friday. I'm 6 days late. What's going on? Well, my son got COVID, got infected by his ABA therapist. Not going to pretend to be happy about that. And it's been a heck of a week, I got to tell you. Thank God he was vaccinated, symptoms were mild, and somehow my 3-year-old ducked the bullet too. So we're back on our feet, sort of. And I'm going to do another episode tomorrow, and I'm going to tell you everything you need to know. But I wanted to take the opportunity of this late episode to share with you guys something important that's been ruminating for a little while now. And I really need to share this with you. So Dr. Ingrid Shaffer is on our scientific advisory board. She's an incredibly famous neurologist who, when she was doing her PhD, argued for this idea that some epilepsies could be genetic. Now we all take that for granted because our kids have genetic epilepsies. But this was an idea once, and Dr. Shaffer was on the cutting edge. So it's appropriate that she wrote this 3-page opinion piece in The Lancet, February 22, which is next week, but apparently it's already out. And I want to read you the title and the last 3 sentences because they're so important. The title of this is Lightning Progress in Child Neurology in the Past 20 Years. Lightning Progress, Dr. Shaffer said. Dr. Shaffer's a neurologist. I mean, she's about as cool as they come, but lightning progress is not something you hear out of the mouth of a neurologist very often. So that alone should get your attention. But let me read you the last 3 sentences. It will not be feasible to design a gene therapy for each pathogenic variant of every genetic disease. So clever strategies, such as those mentioned above, will need to be developed to enable these life-changing therapies to reach a wide variety of patients. That sentence is very important. I'm going to come back to it. The future of child neurology is bright, indeed far more promising than at the turn of the 21st century. Many devastating diseases now have a real hope of targeted therapies, which can cure. She said cure in The Lancet, which can cure not just one, but all manifestations of the disease and offer the child and family the promise of a normal life. I might have that carved in wood and put on my wall. Many devastating diseases now have real hope of targeted therapies which can cure not just one, but all manifestations of the disease and offer the child and family the promise of a normal life. Exactly. So well said. We can treat the symptoms, blah, 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 epilepsy, intellectual disability, sleep, GI, it's an endless list. Or we can go right to the cause of the disease, the deficiency of Syngap1 in the brain, and we can address it with a genetic therapy, and we can cure all manifestations of the disease. This is a huge statement. And it is coming from one of the most famous and important neurologists alive on the planet. And it is in The Lancet. Point 1. Point 2. I was speaking to another very famous geneticist who was encouraging SRF to fund a tool to understand our mutation. So you have to understand, if you've got a piece of paper right now that says you have a pathogenic or likely pathogenic mutation in Syngap1, it's not like someone threw saliva in a machine, got an answer out, looked it up on a table and said, yep, that's pathogenic. That didn't happen. What happened is went through a machine, there was a bunch of analysis, they found a mutation in Syngap1, they looked at it, they consulted with clinicians, and if somebody else has already been through this process, they might have said, yep, that's already pathogenic. Someone's already done the work. This one's pathogenic. But in many cases, they struggled and they hummed and they hawed and they consulted and they said, yes, for a variety of reasons, either molecular biology or clinical presentation or both, we think this is the cause of disease. That's why when people tell me they've got a diagnosis and they're heartbroken and destroyed, I congratulate them because they have no idea how much work and science went into that piece of paper. So I was talking to this geneticist who wants to build a dashboard. And he said to me, I want people making these decisions to have access to the latest information because they don't have it. I know this because I train these people. And I want parents to have access to this information. I said, with all due respect, sir, parents aren't going to be using this tool. Like when you get diagnosed, you have no idea what any of these things mean. you just need someone to give you a hug and hold your hand. They're not going to be using this tool. But I agree with you. We use this tool and we spend an incredible amount of time answering questions about mutations. Just this morning, a very smart parent shared on one of our groups. She said, "This is my genetic report. Can anyone tell me what it means?" And I looked at it and I said, "Good news. You have the least complicated mutation. It's down the middle." So I don't want to lose the plot here. Ingrid, lightning progress. We are on the cusp of genetic therapies. Famous geneticist. And here's what he said to me as we were having this conversation. He said, "Mike, what people don't understand, and what I understand because I'm consulting to multiple companies working on multiple genes to develop genetic therapies." This is what he said to me, and I understood exactly what he was saying, but it was the first time I'd heard it in spoken word. They don't understand that their access to these therapies will be determined by their type of mutation, and they have to understand their mutation. Alleluia, amen. You have to understand your mutation. If you have a Syngap 1 diagnosis, that is too broad. First of all, you got to be able to show someone what your Syngap diagnosis is. In the course of enrolling people in Citizen, I can tell you a lot of people have no idea where that piece of paper is. If you do not have a copy of your genetic report in your inbox, on your phone, in a shareable folder on Google, get it and find it and make sure it's handy. You need to have that piece of paper. Okay, point one. Point two, you need to actually understand what that piece of paper says. And I realize this is a tall order because it's totally in science code, but figure it out. And this is the point that was made to me. He said, parents need to understand that their access to clinical trials, which by the way will dictate who will get the drug when it's marketed, access to clinical trials will be determined by the type of mutation. What is he talking about? So that was point two. Point one was lightning progress. Point two was you need to understand your mutation and realize that it will affect which therapies you get. Point three, let's talk about your mutation types. In the first two cohorts of Citizen, we collected data from 100 people. We looked at those genetic reports. Briefly, a third were nonsense, a third were missense. Nonsense and missense mean that there's a stop codon. The protein never gets completely built. What that means is that you have a healthy copy, a wild type allele, and a mutated copy, a mutant allele. When they're different, they're called alleles, just because everything, they shove so many words into science to keep us all out of their party. But you got to get into the party. So you have a wild type allele, you have a mutant allele. You have a good copy, you have a bad copy. Most of the therapies, this is what Dr. Shaffer said in that sentence one, it will not be feasible to design a gene therapy for each pathogenic variant. So clever strategies will need to be developed to enable these life-changing therapies. What she means, I think, Dr. Shaffer is infinitely smarter than I am, so I could be getting it wrong, but I think she's saying we can't make a drug for every single kid with a different mutation. That would be too many drugs. It would be too onerous, too cumbersome. It's just not practical. But if we can develop a strategy that will help all the kids, regardless of their mutation, that's the right use of funds. And she's right. So generally, all the therapies under development that I'm aware of, and I'm aware of a couple. I'm also under a lot of NDAs, so I can't give you the blow by blow, but there's a lot of this information that's public, the Tango with Stoke, etc. These strategies, what Rick's doing, they're all basically doing the same thing. They're finding a way to make Syngap work harder. And what that means in our children who have a wild type allele and a mutant allele is that both alleles will work harder. So the good copy will make more. 1 times 2, if we have it make more, is 2. And that means that our kids will have enough Syngap. 0 times 2 is still 0. So the bad copy of those patients with a nonsense or a frameshift mutation, 2/3 of our population, will just make more of something that gets chewed up by nonsense-mediated decay and goes away. So this therapy that upregulates Syngap means that the wild-type allele will make more and fill the gap, and the mutated allele will make more nonsense mutants, and they will be decayed. No problem. Back to what Dr. Lal says. Parents need to understand what kind of mutation they have because it will affect their access to trials. So here's the punchline. The other third, so about 1 in 8, 12%, 12.5% of our patients have intronic, deletions, duplicate, very strange mutations. I don't have time to explain. By the way, my son's in that cohort. So if you want to talk about it, call me. But 1 in 8 are like that. I'm not going to explain them, but I will say that everything I'm about to say about missense also applies to them. 1 in 5, 20% of our patients have missense mutations. And a missense mutation, back to my wild type allele, a mutant allele, that mutant allele is being built, but it is getting to the end. And the end matters. The C terminus, the 3', that really, the body interacts with that. Other proteins connect to the end. So if the protein is built and there's an end, then that thing is still out and about. It's not a 0. Okay, it's doing something. Think of it as misfolded. The Syngap protein is 1,343 amino acids long. Think of them as 1,343 little Lego blocks to make a precise shape. And then somebody, because of that missense mutation, went in and changed one of those Lego blocks to the wrong Lego block. I'm really simplifying this. And now that whole protein is the wrong shape because that one block is wrong. And then we come in with an ASO that upregulates Syngap. So 1 times 2 is 2. The wild type allele makes more. Great. But what if that's not a 0? What if it's a negative number and we multiply that by 2? Have we done more harm than good? We don't know. We don't know. And as a result of not knowing, when companies have therapies that they are certain can help 2/3 of the population, it would be crazy of them to give that drug to the missense and the other mutants without fully understanding their precise mutation and if that will help. So for those of us with intronic or missense mutations, we have a problem. How do we solve that problem? Because our children are sick and they need access to these therapies. Answer: we facilitate the study of these diseases, of these mutations. We make sure that people can answer that question. Is this mutation a 0 or a negative? How do we get our heads wrapped around that? Answer, and let me tell you where this answer comes from. Every company I talk to asks me for patient-derived cell lines. Like, Mike, we want to study this in patient-derived cell lines. Can you get us some? I work with Rarebase, who's a CRO, an amazing biotech, and I work with Combined Brain, who's an umbrella organizations. Both organizations have impressed on all of their nonprofit partners, you need to have a bank of cell lines to facilitate the study of your kids. We will help you build cell lines. We have a contract with both of them that we make available to families. So for $9,000, if you have a strange mutation, SRF has an existing agreement with these 2 organizations. Raise the money, get your tax deduction. We will build a cell line on your kid and a same-sex family control. And then we will keep those in the biobank. And any researcher or company who needs those cell lines, we will make them freely available. Oh, but Mike, my cousin's brother's sister knows a researcher and he'll do it for me. With respect to our academic partners, do not pay an academic lab to build a cell line for you. Do not pay an academic lab to build a cell line for you, because here's the deal with academic labs. They will share them freely with other academic labs, taking their sweet time, but they will share them. And as soon as you ask them to give them to a company, an army of lawyers from the IP office at the university show up with a bunch of truly ridiculous and absurd terms and conditions. And they will drag their feet and they will have endless meetings and they will insist that companies cannot be trusted with this material and that they need to protect. Someone actually said to me, we need to protect the patients from these companies. And I said, that patient is my son. And so help me God, you will share that material. It was not a pretty meeting. But it was a needless meeting. It was a needless meeting because what was happening was a university that had genetic material was standing in the way of a company understanding if their therapy helps Syngap 1. So I speak from experience. You need a cell line. And asking academic partners to develop a cell line for you only feels like a good idea. It's actually not a good idea because companies cannot get their hands on it. And we want companies to get their hands on it because companies are the people who make and market therapies. Which is why the Syngap Research Fund makes it possible for families to develop cell lines. Why are you talking about this, Mike? You've mentioned this before. There's a whole article, syngap.fund/iPSC. We know this. Well, here's the problem, guys. I was talking to a family just recently. Wonderful family, eager to get involved, wanted to help their kid. Sent me their genetic report, as families do. I looked at it and I said, hey, good news, you've been diagnosed. Not great news, it's a missense mutation. Here I have a list of a lot of cell lines here on Earth. I know about what's going on at Simon's. I know what we've got. I know what various researchers have. There might be a couple of cell lines I don't know about, but I'm pretty sure I know about most of them. Because all I do every day is talk to people about cell lines and who's got which ones and how do we collaborate and blah, blah, blah. And I said, I'm telling you right now, your cell line I don't think exists, which means that we don't know if that mutation is doing nothing or is doing something negative, which means that in spite of the lightning progress over the next 20 years, when a therapy comes to market, it is not, in my opinion, likely that your son will be given access to this particular therapies, this class of therapies that upregulate Syngap. Family grabs their heart and says, what do we do? And I say, believe me, I understand what you're feeling right now because it's exactly what I felt 4 years ago when I was told the same thing. And at that point in time, I made the mistake of trusting an academic to build a cell line for my kid. And guess what? I can't get that cell line to companies. But I have since made other copies that I can give away, so we're good. But my point is that we as SRF, a public charity in the United States of America that is able to give you tax exemptions, will help you raise $9,000. We'll give you a tax receipt for $9,000, and we'll build that cell line and then keep it in a biobank through our partnerships with Rarebase and Combined Brain. And when an academic or a company needs a copy of that cell line, we'll give it to them. No problem. And they will be able to study your son and his mutation. And they will be able to figure out if the therapies under development right now will help your son. Wonderful. Parents are very excited. Mom and dad have to talk, but for the most part, we're good. Guess what happened next? They go to their neurologist. And this is why this is on my heart right now. And here's the deal with neurologists, right? They're very smart people. They went to medical school for a long time. They've committed their life to helping people with epilepsy. God bless them. And I'm grateful they exist. And we cannot expect them to fully understand Syngap 1 because they have to understand all of neurology, and there's thousands of monogenic diseases, and it's really complicated, and every disease is different. So it's reasonable to them that we go into them with paper by Dr. Shaffer, Neurology 2019, great paper. And we explain to them, this is Syngap, these are the symptoms, it's blah, 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 blah. That's appropriate. It's appropriate that we give them some breathing room and some time to catch up and offer them to consult with other experts in this gene. It is equally appropriate, then, that we would ask them not to have too many strongly held opinions about the state of Syngap research. I do nothing but Syngap research all day, every day, with a lot of neurologists and cutting-edge researchers, arguably some of the best in the business. And I'm very comfortable saying, with nothing but admiration and respect for my neurologist colleagues, that every neurologist in America is not fully up to speed. That's a safe statement. Trust me on this one. So when this neurologist said so the parents go see their neurologist and they say, we're working with SRF, and SRF wants us to build a cell line because this missense mutation could get ready for therapies. And this neurologist said two things to them that frankly really upset me. And I think it was inappropriate. I've re-recorded this episode a number of times because I've struggled with a polite way to express my feelings on this. I think it was really inappropriate. This neurologist said two things. Thing number one, he patted them on the head, and he might have thought he was being compassionate, but frankly, he was being condescending, and he was wrong. He patted them on the head, and he said, we're not going to have a therapy for this disease for like 10 years. Sir, you're wrong. We're going to have clinical trials in as soon as 2 years. We could have marketed therapies in 3 or 4, if not sooner. So I don't understand where you got that number, but it's not wrong. And the second thing he said is, don't do a cell line. That's a waste of your money. Again, he thought he was being compassionate, maybe, if I'm generous, but he was actually being condescending and incorrect. Trust me on this one. Every drug company, every researcher, everyone I've talked to, the second or third sentence is make sure you get a cell line. So thank you for seeing our kids. Thank you for treating kids with epilepsy. Thank you for being an amazing neurologist. But stay in your lane. We are talking about how you facilitate research on little-known monogenic diseases. And the way you do that is you identify rare mutants and you build cell lines and you make them freely available to researchers because it takes months and months to build cell lines. And we can do it. And we can get that. We know you're going to need them. We don't know what you're going to use them for, but we know you're going to need them. So we can build them now and have them ready. Because we're making lightning progress in the past 20 years. And we can help a lot of children if we work together and make sure that as many mutants as possible have access to these therapies by identifying the ones that are odd and missense and studying them now. I encourage every single family with a missense mutation to reach out to us, see if there's a line already exists. If you have a 1030G to A, you're good. If you don't, we should probably build one. And invest in those cell lines and make them freely available to academic and commercial partners as fast as possible. Because we are all in this together, and we've got to make sure every kid with Syngap gets the help they need. Thanks for listening.